everybody. Thank you all. Welcome to Octopi's Take 3. On this time, our video is going to be about reviewing the 3 laws of motion. You know, Isaac Newton's 3 laws of motion. You know, the guy whose apple fell on his head? Or am I referring to the wrong guy? I think I'm referring to the right guy. What do you think? Well, anyways, we're going to be referring about the three basic laws of motion. So I'm going to just list them off. Here we go. So we're reviewing the 3 laws of motion, okay? Just in case you missed like 2 seconds ago. Well, so Newton's first law of motion says that an object in motion will stay in motion, and an object at rest will stay at rest unless acted on by an unbalanced force. Now, I know you're thinking, but if an object's in motion like a ball, eventually it'll stop. Yeah, it's because of friction, which is an unbalanced force, I think, because that's the only thing that stops it. Then if you put a ball on a slanted table or on your desks at school, they're super slanted, so your pencils keep rolling down and it annoys the dog out of you. You're just like, why does it keep rolling off my desk? That's because it's slanted. So basically, I'm going to summarize it. So, an object that is not moving will not move until something pushes or pulls it. And an object that is moving remains moving until something pushes or pulls it. And all objects resist having their motion changed. And that is called inertia. So the bigger the object, or the more mass it has, the greater its inertia. So, say like a huge pickup truck or an RV or something, you know, you're trying to push it along, you're just like, this is so hard. Once you get it going, though, it gets easier. You know that? And then whenever you try to push like an itty bitty little truck, you can generally do it by yourself. And you're just like, oh wow, this is pretty good. That's inertia. And then if you like roll down a hill, the bigger truck is also harder to stop. So today we're going to test that with, well, basically an RV and a itty bitty little car. Okay, they're right over there. I'll show you in a second. So this is a small car that we're going to be testing. See how itty bitty it is? See it? Yep. Okay, this is a small car. And then the RV is also like 5 times as big as that. This thing weighs in, I'm not sure how much it weighs, but it is as big as me. We're going to test them in a way you would never expect. Okay? Let's do it. Okay, guys, come on, bring it on. Okay, small car, go. What? That was itty bitty. What in the world? I didn't even feel that. Jeez. Get out of here. I wonder how much damage you got. Ugh. Dude. I didn't say go yet. My visor broke. Ugh. Nah. That hurt. That hurt really bad. I launched like 3 feet off the screen. That's a long ways for an octopus like me. Really. I almost got turned into a sushi bar over there. Or squid bar, however you put it. I don't know. Jeez, well basically that's Newton's first law. It's basically the bigger the mass, the bigger the inertia. That's the inertia thing. The inertia was basically how hard it was for me to stop it. That thing just stopped like as soon as it hit me. That thing completely just barreled me over. Look, that hurt. You know what? I'm gonna come over there and just, okay. Man, I don't even know. So, alright, so in a second we're going to say Newton's second law. Just kidding, I mean, we're gonna go in more depth with the first one. So basically, so you want to know about inertia and stuff. Inertia is the tendency to resist a change in motion. That RV over there completely barreled me over, didn't even give anything. And so that had really big inertia because it didn't like barely slow down as soon as it hit me. That thing, on the other hand, has like no inertia. It has a little bit, not a lot though, because as soon as it hit me, it completely just stopped on my tentacle. I was like, what? This thing's tiny. No, I'm totally kidding. But anyways, yeah, the RV had a really big inertia, and this one just had a tiny inertia. And, well, high five, guys. For real, we're doing the second law now. Alright? Alright. Here we go. So the second law of motion states that the force of an object is equal to its mass and its acceleration. So change in motion only occurs when a net force is exerted on an object. And a net force is like how many newtons you're using. And how do you measure newtons? Not going to bother explaining that because it takes a long time. We don't really have that long. So basically you use newtons. So say like the net force is the total amount of newtons used pulling it in one direction. So say like this is like 10 newtons pulling me this way. Like 5 newtons pulling me this way. 10 newtons will win. And then, so basically in order to measure the net force, you subtract the 5 over here from the 10 over here and you end up getting 5 net force pulling me this way. And then, so if an object is acted upon by a net force, the change in velocity will be in the direction of the net force. Oh, that's what I just said. What in the world? Okay, so the acceleration of an object depends on its mass. Okay, so the more mass an object has, the more inertia it has, like the freaking RV over there, the harder it is to accelerate. More mass means less acceleration if the force acting on the objects is the same. So if you use like your hand to push both, that little car is way easier to push than that one. And that one weighs like 4 or 5 pounds. I know it doesn't sound like a lot, but for an RV like that size, I mean, look at it. Look at it. Look how big it is. I'm barely taller than it. I mean, jeez. That thing is like, I don't even know. So, here we go for the third law. Here we are. The third law states that for every action, there's an equal and opposite reaction. A reaction is an action that happens again. Did you guys learn English? Goodness. Re means again. I'm so smart. Well, basically, react. Nah, I'm just kidding. Alright, so when one object exerts a force on the second object exerts an equal force in the opposite direction of the first object. I mean, watch. I'm just leaning against this. The only thing that stops this whole thing from, like, crumbling is that thing, the force. The force is crazy. I mean, like, anytime I lean against something, there's going to have a force that's pushing against me. So, in opposite direction of the first object. So this thing, I'm pushing this way, like this way. This thing's pushing towards you guys. The only thing that's keeping it in place is that it's a still object. I mean, really. So the force exerted by the first object, that would be me. I'm not an object, though. Jeez. I'm totally animate. I'm not an inanimate object. I'm moving. So the force exerted by the first object is the action force. So the force exerted by the second object is the reaction force. So this is my reaction. I'm just gonna chill here for a minute. Okay, guys? Ah, man, this is getting really nice. Comfy. I love being comfy. Yeah, again? What does that guy have against me? Oh well. Well, I'll see you guys later, okay? So, luckily I don't have any bones. That breaks physics. Yeah! No, I'm just kidding. Well, I don't have any bones. I'm all organs and junk. So, luckily he didn't break any bones. Since the bones are non-existent. So, I will see you guys in whatever next video I decide to host. And this is where all the credits and outros and everything come in. Stay awesome, everybody out there. Bye-bye.